Hello students, and today we're going to look at graphing parabolas in Focus-Directrix form. What you're going to want to have on you, the outline of notes I gave you in class, and then a pen or a pencil. So basically parabolas, what are they? Well, parabolas are what's known as a conic section. We're going to look at conic sections a little bit more in the next unit. A parabola is in a conic section in which any point on the parabola is equidistant from a fixed point called the focus and a fixed line called the directrix. So basically this is what it is. It is a U shape like we've been seeing, and we have this dot in the middle right here, this focus, and it's in the middle. So every piece of if you draw a line from the focus to the parabola, it is equidistant to the directrix that's behind it. I like to think of these kind of parabolas as the satellite dish that you see. You have that point in the middle, that's where everything goes to, and then it bounces off the satellite dish, which is our parabola. So this is also going to allow our parabolas to no longer be just up and down. So these are what these are going to look like. X squared equals 4 times p being some value, times y. Now you're going to open up or down based on what p is. So if p is positive, you're going to open up, and if p is negative, you're going to open down. But now our parabola on this can also open left or right. Same thing's going to happen. If our p is positive, it's going to open right, and if p is negative, it's going to open left. So you're going to want to keep that in mind as we continue to look. I like to think, way to remember if it's up or down or left and right, x squared always opened up or down no matter what before, right? So I like to think x squared up and down, y squared something new, left or right, okay? P is the number of positive or negative units from the vertex to the focus. So that allows us to find where that focus point is in the middle of our parabola. But let's make sure we can find that P first, okay? So to find the P, what you're going to do is you're going to take the number that's in front of the letter on the side, what's not squared, and you're going to want to set it equal to 4p. So I'm going to go 4p equals negative 12. Solve for p. So divide by 4. I know my p here is equal to negative 3. Being able to find that allows me to find my focus, allows me to find my directrix. It's a lot easier. So now let's do this one. So I'm going to take this piece right here. Whoop, not the x. Whoopsies. 4p, and I'm going to set it equal to 8. So divide by 4. So I get my p is 2. Same thing here. Let's take the 6 and set that equal to 4p. So I'm going to divide by 4. So I'll get 3 over 2 equals p. So not hard to find the p, it's just keeping that in mind. Let's actually do a problem here. So I got this first example, negative 4y equals x squared. And I'm going to identify a whole bunch of stuff here. There we go. So very first thing, my vertex. Notice we've been at the origin because my vertex, there's nothing with this y and this x. So your vertex is going to be 0, 0. So I'm going to put a big dot there at 0, 0. And I'm going to put a big V there too. So I don't get lost. He doesn't get lost. Because I find that if I put the focus and the vertex and all that, he gets really lost. So I like to label these with a V and an F for my focus, okay? So now let's find what our P is. Remember, that's basically this guy equal to 4p. So negative 4 equals 4p. So if I divide by 4, I'll get negative 1 equals p. So my p is negative 1. Now, it's an x squared, right? We're used to x squared. So this is either an up or a down. Since my p is negative, we're going to be going downwards. This helps us think, where's your focus going to be? So if I'm going down, I know my v or my parabola is going to look something like this, right? So I know I need to go down 1 here to find my focus dot. So it's going to be right here. I'm going to put a nice F right by him so I don't get lost. There we go. So my focus is at the point 0, -1. Okay? Now the directrix is the other side of the vertex, but it's the same distance away. And directrix is a line, okay? So my directrix is going to be right here, sitting at 1. So now that's a line, so that's going to be y equals 1 for your directrix, because that's a line, not a point, okay? Now, you're probably saying, what is this focal width? Well, focal width, what that is it allows us to figure out how far away from my focus is my parabola going to go. So your focal width is going to be whatever this number straight is, except without the negative. So my focal width is 4. What this means, my parabola around the focus will be 4 units. So my parabola will have a width of this. Okay, so around the focus I need to have a width of 4. Well, it has to be equidistant, right, from the focus. So that means on either side of my focus I'm going to be 2 things away, right? So then they're equidistant from that focus. So now what I can do is connect my dots, and now I have my parabola drawn. Axis of symmetry is the same thing. It's where you can fold this guy. Well, I can fold him right here on x equals 0. My domain, well, it looks like I'm covering them all, so -infinity to infinity. And my range, you're still just using the vertex, okay? You don't care about the directrix, he's just kind of bouncing off things, okay? So my range is from -infinity, because you start at the bottom, and go to the top, so till 0. Let's try another one here. So I have the problem -y² equals 20x. Hold on. There's a negative in front of that y². That's can't have that. So let's get that -1 that's in front of that y². Let's get it away. Okay? Let's make it look nice. So I'll get -20x. Cool. Now it looks nice. So to find my p, I'm going to set that -20 equal to 4p. Okay, let's divide by 4. So p equals -5. Got it. Now, open up, down, left, right. Well, it's a y². That one's a little odd, so it's going to be left to right. Since it's negative, we know it's going to be a left opening parabola. My vertex is still 0, 0. So I'm going to put a big dot there and put a big nice V so we don't get him lost. So vertex, he's 0, 0. Now, my focus is to the left of that, 5 units. Right here. So that's going to be like the dot in the middle of the satellite dish. So let's put a big F there so I don't lose him. There we go. So that dot is -5, 0. My directrix is going to be the other way, same amount of units though. So it's going to be right here. Nice line. Whoop. Can't draw a straight line to save my life today. So I got x equals 5, right, for that directrix line. So my focal width is going to be this number right there, 20. Well, but remember, so that means my parabola has to have a width of 20 across my focus. So split it in half, basically, so it can be even on both sides. I'm going to have 1 here, 1 here, so then my parabola is going to open nice and big. Just like that. There we go. Axis of symmetry. Now remember when I said it's going to always be x equals? Sorry, it's not, because this is a left facing one, right? So this is not going to be x equals, it's actually going to be a y equals 0, right? Because that's where I would split it. My domain, Ooh, I'm not covering all the domain anymore, am I? Because it's a left and right. So I'm only going to 0. So it looks like I'm starting at negative infinity and ending at 0. And then my range, though, I'm getting all the negative y's and I'm getting all the positive y's. So negative infinity to infinity for this one. Now, let's move the vertex away from that origin. So what this is now going to look like is something like this. So basically inside the parentheses you're going to have a K and an H, kind of like it looked like when we did our vertex form with the regular parabola, right? So basically we're just going to need to want to think of where's my vertex first. So we have this problem here. Notice this one is moved. So it's x plus 2 squared equals negative 4y minus 1. So let's first find our p-value. So this is same thing. I'm going to set negative 4 equal to 4p. So I know my p is going to be negative 1. Now, I need to know where to put the vertex first. So my x value is going to be tied with the x, and my y value is going to be tied with the y. Kind of makes sense, right? So it's going to be opposite on both of these than when you see, though. So I'm going to have a negative 2 there and a positive 1 there. Okay? Not too bad, right? My vertex then, negative 2, 1. Let's put a dot there. Up or down? Looks like it's going to be down, right? Because it's x squared. So that's normal. It's negative, so it's going to open down. My focus then is going to be 1 down from that. Oh, almost forgot, put my V. So my focus is going to be right here, down from my vertex. So let's put a big F there. So that would be the point negative 2, 0. My directrix then is going to be the line going right here. It's 1 away from the vertex, so that's going to be y equals 2. Focal width, it's going to be that 4 right there. So around my focus, I'm going to put 2 dots here, just like that. Let's go ahead and draw. There we go. My axis of symmetry, that is going to be x equals negative 2, right? Because that's where I can fold him directly in half right there. My domain is negative infinity to infinity, because it goes from, catches all the x's. But my range is only from negative infinity to 1. And that's the end of this video. See you later, Savers.